Hey guys, in this video we're going to be talking about multiple transformations. So in the past couple of videos we've seen different transformations in Unit 4. So the first one is translation. Then we saw translation. Then we saw dilations. So this is just your shrink and stretch. And then we saw your reflections. And when you're dealing with a function that has multiple transformations, there is an order you must follow. So let's move this a little down over here. So you have an order you must follow. And the first step is horizontal translation. Then you have your dilation, reflection, and finally your vertical translation. Your vertical translation. Vertical translation. Perfect. So let's look at a couple examples of what this means. Just a little this way. So let's say we had f of x equals 2x squared minus 4. So I could make an x and y table, and personally I believe that's quicker, but for the sake of this example, let's just do the transformations. So we have to start by identifying our parent function. So based on our parent function, we see that we have, let me draw this. Perfect. Based on our parent function, we see that there's an x squared, so we know that's a quadratic. So this is a quadratic, right? Quadratic, just over there. So we see that we do not have a horizontal translation. Do we have a dilation? So this is a stretch or shrink, and yes, we do. We have a 2 out here. So we're going to start by drawing our parent function. So our parent function can be in, let's make it yellow. So our parent functions will be 0 over here, 1, 1, and then 2, 4, 2, 4, 4. Perfect. So for our parent function, we have the points plotted out. So let's see what it would look like with a stretch or a dilation. So with the dilation, we're increasing the y values by a factor of 2. So if this is 1, I'm going to multiply this 1 by 2, so that is 2. So 1 times 2 is 2, so your new point is going to be here. And this is also going to be here. So this point is at 0, 0. So 0, the y value here is 0. So 0 times 0, 0 stays where it is. The y value here is 4. So 4 times 2 is 8. So 4, 5, 6, 7, 8. So I'm going to move the graph further down. Okay, this should be good. Okay. Then extend this. Perfect. So then we have 4 times 2, that is 8. So 1, 2, 3, 4, 5, 6, 7, 8. Oh, we still have to move this down. Okay, actually I think this is fine. So 4, 5, 6, 7, 8. So right here. 6, 7, 8. This is good. And over here as well. Okay. So now that we have this, we can get rid of the yellow circles. So this was our parent function. The yellow was our parent function. And it looked like this. The pink is our transformation, one of our transformation, which is dilation. But we're not done yet. We have the vertical translation, and that's And I know that because there are no parentheses, so we know that this is a vertical translation. So that means I move down by 4. So the pink point. So once you're done with one function or one part of your graph, I like to erase it so that I don't get confused. So I'm going to move each point down by 4. So start off by this point right here. 1, 2, 3, 4. We know it's going to be 4 this way. Then it's going to be 1, 2, 3, 4. 4. Then 1, 2, 3, 4. Perfect. So then you can draw your lines. It's not perfect, but it works. So there we go. And then erase the pink. Perfect. So this is what your graph should look like at the end. So this is the graph for the function f of x equals 2x squared minus 4. So now let's do another one. Let's do this over here. So g of x equals negative 1 over 2 times 2x minus 3 plus 1. So we have the order over here, so let's bring that down. So duplicate. Perfect. So the first thing we need to look for are horizontal translations. And we see that there is one over here, so by negative 3. So x minus 3, because although there are no parentheses, it's up there with the exponent. Like you see the plus 1 over here, that is a vertical translation. But if it's with the x, so this is with the x, we know that this is horizontal. This is a horizontal translation. So we start off by identifying what parent function we're dealing with. So what is our parent function? So we see that there's an 2 raised to the power of x. So we know that that is an exponential or power. So that's going to look like 0. Then we're going to have, not 0. 2 to the 0 is going to be over here. So when 0, Okay, so kind of like this. 2, 4. Okay, this is good. So this is your parent function for the exponential graph. So now we have to deal with the horizontal. Remember, when there's a negative, we go to the right for horizontal translations. So we're going to move 3 points to the right. So 1, 2, 3. So right over here. Then we have 1, 2, 3 right here. 1, 2, 3 over here. 1, 2, 3. Finally, 1, 2, 3. Perfect. So this is our new graph. Again, I like to erase my parent functions, but since we're using different colors, it's easy to recognize. So let's move on to our next transformation. So that is dilation. So we have a dilation of 1 over 2. So that means we are shrinking the graph by a factor of 1/2. So a quick way to tell is look at your y value. So this is a 4. So 4 divided by 2 is 2. So we know that the new y value is going to be 2 for this point. So this point went down. For this point now, we're going to look at 2. So this point is at the value 2. So 2 divided by 2 is 1. So it's going to go down 1. And then for this point, it's at 1. It's at 1. So 1 times 1 over 2, or 1. Yeah, so that's just 1 over 2. And this goes down 1 over 8. Perfect. So it's going to look like this. And then you're just going to connect the dots. And not finally. So next we have our reflections. So let's use this color, reflections, and we see that it's outside. So we know that the x-axis is the mirror. So the same kind of thing. We're gonna have, and then this is 1. This is 2 away from the line, from the axis, and that's it. So, and then we're going to connect the points. Draw our arrows. Boom, done. Now we have vertical translations. Our final one, that's +1. So we're going to move the graph up by 1. So we know this is going to be here, here. This is going to be here. Right about here, I would say. And this would be here. So you see it kind of gets congested if you don't erase your graphs. But let me try drawing the lines. Perfect. So the green is your final. So let me erase the other graphs. So just the green, right? So oops, okay. Okay, perfect. So we can kind of just put that there. So this is what our function would look like. And don't forget the asymptote for these functions, for the exponential or power function. Okay, so let's look at one final example. In this example, I'm not going to be doing the multiple graphs. I'm going to be using the table. So this might help a lot of people who don't have much time on quizzes or tests, or just want to get their homework done quickly. So we don't have to remember the order in this case. So all we're going to do is create an X table and a Y table. So right over here, we're going to plug in the points -2, -1, 0, 1, 2. And that is because we are dealing with an absolute value graph. So when we plug in -2, so when I plug in 2 times -2 minus 1, we're going to get 2 times -2 is -4. Absolute value of -4 is 4. 4 minus 1 is 3. Here we have 2, -1, minus 1. So 2 times -1 is -2. The absolute value of -2 is 2. 2 minus 1 is 1. And then here, 2 times 0. So value that minus 1. 0 minus 1 is -1. And then we have, and then we have 2, 1, 2. So minus 1, that is 1. 2, 2, minus 1. 4 minus 1 is 3. Perfect. So we have our points over here. But let's just do the transformations as well. So just so you can see that, you get the same answer. So remember, our first transformation was horizontal, and we don't have any horizontal. We don't see anything adding or subtracting inside the absolute value function over here. So that's done. Next is our dilation, and we see that we have a dilation was, okay, pink. So we see that we have a 2. So our absolute value function used to look like this, but now we have to stretch it by a factor of 2. Oops. By a factor of 2. So that would look like this. So we're just increasing the slope, if you'd like to say, of both sides by 2. So it's going to look like this. Again, not perfect, but here, let's do this one a little better. Okay, much better. So it's going to look like that. So our pink one is our new one. Then we don't have any reflections. We don't see any negatives inside or outside for the x being multiplied with the x. So now we're going to move on to our last one, which is vertical translation. So we're going to move everything down 1. So your final graph should look like this. Perfect. So now I'm going to erase the pink and yellow lines. And so this is what we have from doing the transformations in order. But let's say you did them using the table. So let's plot it using the table. So -2, 3. So -2 is here. And 1, 2, 3. 3 is here. So we have a point here. And then we have -1, which is over here. 1, so point over here. 0, and then -1. And then we have 1, and then 1. And then finally, 2 and 3, which is over here. So as you can see, it's the exact same graph. Like the points match up, the connecting of the points line up as well. I know it's not perfect, but it lines up exactly. So either way, whether you use the order for transformations or you use the table, you're going to get the correct answer.